Hello and welcome back, everybody. Today in not calculus, geometry, we'll be looking at the equations of a circle in 2 dimension, and then we're going to derive what that circle looks like, where the center is going to be at some fixed point and also of a certain radius. So here you can see underneath below over here, that's what we're talking about. We're going to first derive the equation of a circle, first with the center at 0 and 0, and then afterward we'll look at the equation of the circle where the center is going to be somewhere else. But before we do so, I want to introduce a new terminology that you guys need to actually know, and it's something that we've been kind of using in the past, but we never really gave a formal word for it. So here it is. The word is actually called locus, and locus by definition in geometry, at least, or in the math terms, it means the set of all points. So in replacement, you can say the locus of points, or rather than the set of all points. So when it comes to the equation of a circle, we want to define it by the following then. The circle is going to be defined as the locus of points that are equidistant to a fixed point. So that fixed point that we're talking about is going to be the center, and that distance that we're going to be looking at is going to be the radius then. So underneath over here, what I'm going to do is we're going to go ahead and sketch out what a circle looks like in on the coordinate axes, where the center is going to be at 0, 0. So here is your circle over here, center at 0, 0, and your radius is going to be of a certain radius. Let's go ahead and say the radius is called r then, okay? So from the center, we're going to go ahead and draw to some arbitrary point, which will denote as x comma y. The distance is going to be r, as we said, because that is the radius of the circle. And this point over here we'll call P is going to be a point that's going to be on the circle. So it's going to be a part of the locus of points. Finally, the origin is going to be represented as point O over here, which is going to be 0, 0. So if we put it all together, what we can do is we can focus on the bottom part over here, where we can create a right triangle. The horizontal increment is going to be x, because that's the distance horizontally from point O to point P, whereas vertically, that's going to be y, because that's the vertical component, or the change of y, from, once again, point O to point P. So since we have that right triangle with all the sides, then we can use the Pythagorean theorem to derive this equation of the circle. So in here, then that means by the following. So by the Pythagorean theorem, then the result is that x squared plus y squared is equal to r squared, where r is supposed to be the radius of the circle. So right there, that is going to be my general equation, where the center is going to be at 0, 0 then. Okay, so that's pretty much it. Nothing, fancy about that. So pretty straightforward for the most part. But I want to make this equation a little bit more versatile, if possible. Meaning, what I want to do is I want to look at, well, what happens if your center is not there? What happens if it's going to be somewhere else, like say 2, 1 or negative 5, 4 or so forth? So then that means that we have to do kind of like a modification or a shift. So underneath over here, let's go ahead and draw that then. So here, that is going to be my graph now. And let's go ahead and say that your center is going to be at some point, we'll go ahead and call A comma B. So that's going to be my new center. And then from there, what we're going to do is we're going to go ahead and generate a circle. So that right there is what I'm going to try to find the equation of. So just like before, what we'll do is we're going to go ahead and pick some arbitrary point we'll call P of xy. That's going to be on the circle. So just like before, this OP right here, that's going to be the radius of the circle, which we'll denote as R. And then we're going to look at this right triangle, just like the one that's above. Now, in this case, that's going to be a little bit different because, well, your center is no longer at 0, 0. So we're still going to have to solve for each one of this. This guy right here, that's the change of x in the from O to P. So then that means that it's going to be x minus a, because it's like x2 minus x1. Whereas for this part over here, that is going to be the change of y, and that's going to be y minus b. So similarly to before, what we can do is put it all together. So now my equation of the circle, which is a little bit more strengthened because we're no longer restricted by having the center at the origin, is going to be x minus a quantity squared plus y minus b quantity squared is equal to r squared, where once again, your radius is still going to be equal to r, but my center is no longer restricted to the origin, but at some point a comma b. All right, so now let's go ahead and solve for, some of these problems that you might see in the homework assignment. The first one over here is, what is the equation of the circle with a center at -3, 2, and its radius is of 5? Well, you don't have to do a lot of work because we just derived the equation, so we can just go ahead and use it right off the bat. So x minus a squared plus y minus b squared is equal to r squared. So that's our equation of the circle, where the center is going to be at some arbitrary point with a radius of r. Literally, we're just going to throw everything in then. So x plus 3 quantity squared, because it's x minus 3. And then plus y minus 2 squared is equal to 25, because it's 5 squared. And if you're not asked to do anything else with the equation, you can probably just go ahead and leave it. Now, what's nice is in this form, you can actually do a lot more algebraically because it's so simplified. Here's what I mean. So for example, over here, what I can do is maybe plug in some points to see what are some coordinates that are going to be in the circle. So for example, over here, maybe I can plug let x equals to 0. And then as a result, I can solve what y is equal to. So if x is equal to 0, then I'm going to get 3 squared plus y minus 2 squared is equal to 25. Let's see, y minus 2 squared is equal to 25 minus 9. So that is going to be equal to 16. So y minus 2 is equal to plus or minus 4. And so y is equal to 2 plus or minus 4. So that tells me that I have 2 points right there that I just solved for on the circle. When x is equal to 0, y can either equal to 6, or when x is equal to 0, y can equal to -2, because it's 2 plus 4 or 2 minus 4. So that's 2 points on the circle, which is a lot easier to kind of like just plug in, as I said. Okay, now let's go ahead and look at a different one right here. Sketch out the graph of the circle with the following equation by finding its center and radius. So note, what I have right here is an expanded form of what I have right above. So what I'm trying to say is I need to take my equation and change it so that it looks like this format over here, where I can recognize what is the center and what is the radius of the circle. So taking my equation right here, let's go ahead and do that. I'm going to go ahead and take all the x values and I combine them together. So we have x squared plus 4x, and then plus y squared minus 8y is going to be equal to 5. So note, all the x terms are next to each other, all the y terms are next to each other, and the constant is going to be over there on the right. Now, that doesn't necessarily mean that we're done, because we need to change it a little bit more. Note that what we have here is what we call a completed square form. So what that means is that I need to kind of like introduce something in order to complete the square. Now, for those of you guys that don't remember, just let me do this on the side. Let's say that we have x squared plus 4x over here, and I want to complete the square. Okay. Now the question is, what do I have to add or subtract, or sorry, what do I have to introduce in order to get a perfect square? Well, if you look at some of the previous examples I have above, let's go ahead and work backward on this. Suppose I have x plus 5 quantity squared, and I expand the whole thing out. That's x squared plus 10x plus 25, because you're using FOIL. Note that the middle term right here, it's twice this term over here that I underline. Whereas this term right here at the very end, where I need to add, that is going to be the square of the term that I need to introduce. So working backwards over here, you'll notice that I have a 4, right? Well, I'm working backward by knowing this term. I want to find out what this term is. So that means that I need to take that 4 and then divide it by 2. So 4 divided by 2, which is equal to 2. Then if I square it, then that is going to give me the term that I need to add, which is going to be 4. So if I add 4 over here, then that's going to give me the perfect square. And that perfect square is going to be x plus 2 squared. Okay, so going back to what I was saying over here, let's go ahead and do that. I am going to change this over here so that it's this x squared plus 4x, and then we're going to go ahead and say plus 4 because I need to get a complete square out of this. Then for the other part, we'll do exactly the same thing. Y squared minus 8y, and then we're going to add something to make this a perfect square. That's something, once again, thinking about what we just did. We're going to take the -8, we're going to divide by 2, and then square it. -8 divided by 2 is equal to -4. When you square it, that's equal to 16. So that's what I'm going to add then. On the right-hand side, you still have the 5, right, that we have earlier. And let me go ahead and change it actually back over here. So then that way, you can see what is it that I add and what I can subtract according to what I have. So this is going to be all red, so x squared plus 4x. So you can see everything that's green is what I introduced then. Now, I added the 4 and the 16 to the left-hand side. I need to balance the equation. So what that means is I need to add 4 and also 16 to the right-hand side. Okay. So now we can get the complete square of each one of these. This one right here becomes x plus 2 quantity squared, whereas this one right here becomes y minus 4 quantity squared. And that's all equal to 5 plus 4 plus 16, which is equal to 25. So my center, according to this equation, is going to be at -2 comma 4, whereas the radius of the circle is going to be equal to 5 because it's the square root of 25. Remember, 25 is equal to r squared, so that's the reason why it's that. So now we can go ahead and put it all together and see what the graph actually looks like. And let's just go ahead and use a little bit of technology so you can see how that works then. So I'm going to go ahead and change the screen. We're going to go to decimals over here. Okay, so clear this over here. We have the equation x minus 2 quantity squared. And then actually, I think it was plus 2. So let me go ahead and change that over here. So plus, and then we have plus, and then in parentheses, y minus 4, I believe it was. So let me go ahead and put that in. And then close parentheses squared, and that is all equal to 25. So you can hopefully see there's your circle that we're talking about. Your center is located at -2 comma 4, as we said, and then your radius is going to be 5 in this case. So let me just make sure, double check that it is the equation. Yes, there it is. Okay, so now we can just go ahead and sketch the graph then. All right, so that is the basic idea behind it. So hopefully it should be okay. Finally, for this last one right here, let's go ahead and see if we can do a little bit of analytic geometry then, okay? For this problem, it says find the equation of the circle with 1, 1, 3, 5, and also 11, comma 1 on the circle. So these are points that are going to be on the circle, and I want to find out what the equation is going to be. Now, if we were to kind of sketch that out just to see what that looks like, which is always a good place to start, here is what we have then. Let me go ahead and take this line and move it over a little bit because we're going to need a little bit more space than that. Okay, so here is one point, which is going to be 1, comma 1. Here's another point, which is going to be 11, comma 1. And then the last point over here that's given is supposed to be 3, comma 5. So this is going to be A, this is going to be B, and then this is going to be C. Now, if you were to just dive into this problem, the way you can do, well, there are technically many different ways that you can do this problem. The one most common way is to use a general equation of the circle, which is going to be something similar to this guy right here, and then solve for a system equation. Here's what I mean. My equation of the circle is supposedly x squared plus y squared plus ax plus by plus c equal to 0. If you take your equation of the circle that we derived from earlier, which is this over here, we can expand it out so that it always comes out looking like this guy right here. And so the reason why we use this is, well, at this point, A, B, and C are coefficients that we need to know in order to know what the equation of the circle is. The way we can solve for those would be by plugging these points in there, A, B, and C. So let me show you that then. If I take point A and plug in 1, 1, now keep in mind, x is 1, y is 1. So then that way we get 1 squared plus 1 squared plus 1ax plus, oops, sorry, not 1x, plus 1a in this case, okay, plus 1a plus 1b plus c is equal to 0. So if we clean that up a little bit, that is going to give us 2 plus a plus b plus c is equal to 0. Then we can go ahead and do the same for the other point, okay? If we take C and plug it in, actually let's take B, plug it in, let's see what happens. So if I plug in B, we're going to get the following then. 3 squared, that is going to be equal to 9, and then plus 5 squared, and then plus 3a plus 5b, and then plus c is equal to 0. Clean that equation up, you get 9 plus 25, which is equal to 34, and then plus 3a plus 5b plus c is equal to 0. And then finally, if we take the last point and plug that in, so c, which is 11 comma 1, we are going to get 11 squared plus 1 squared plus 11a plus b plus c is equal to 0. So that right there would then give us 122 plus, looks like 11a plus b, and then plus c is equal to 0. And supposedly what we need to do now is take this guy right here, take this guy right here, and take this guy right here, and form a system of equation, so then that way we can solve a, b, and c. Now, needless to say, that's going to take a little bit of time, and for those of you guys that are still in Algebra 1, you might have done 2 equations and 2 unknown. 3 equation, 3 unknown would be 1 tier up from that, so that might be a little bit harder. So we'll save that for next time. The way that I presented this problem over here is a little bit easier than this. You don't have to go through all this method, and here's why. If you look at the slope of what of the points that I created, you'll notice that there's something unique actually about it. So over here, that right there, if I were to look at the slope of AB, the slope is going to be 5 minus 1, which is 4, divided by 3 minus 1, which is equal to 2. So the slope is equal to 2. Now, for this part over here, if I create its slope, the slope is going to be 1 minus 5 divided by 11 minus 3. So that is going to be equal to negative 4 over 8, which is equal to negative 1/2. Hey, note the slopes are actually negative reciprocals of each other. So what that means is this guy right here is a right angle. Now, if you're wondering, well, how does that actually work out? Keep in mind that all these points that I gave you, A, B, and C, are on the circle. So what that means is if this angle right here, let me go ahead and draw the circle so you can see it. So here is A, here is B, and then somewhere over here is going to be C. Since that angle right there is a right angle, then that means that AB, sorry, not AB, but AC is going to be the diameter, because remember, this right here is 180 degrees, 90 degrees, which is an inscribed arc. So that tells me that the points that I'm working with right there, those are going to be making up a diameter. So what that means is all you need to do is just find the center of AC then. Well, that's easy enough. The center of AC, that actually is going to be the center of the circle in this case. Well, here's 1, 1, here's 11, 1. So then that means that the center has to be the average using the midpoint theorem. So 1 plus 11 divided by 2 is going to be equal to 6, and then comma 1. As soon as you have the center, you can then find a radius, because OC is the radius or AC is the radius. So that definitely looks like it's going to be equal to 5. So my equation of the circle is x minus 6 squared plus y minus 1 squared is equal to 5 squared. And then we can just go ahead and leave the answer like that. All right, thank you so much for watching. I will talk to you next time then. Goodbye.